Today we're going to talk about the 6 trig functions. Now, if you'll remember back in geometry, we talked about 3 of them, sine, cosine, and tangent. We learned that nifty little catchphrase, SOHCAHTOA. Of course, SOHCAHTOA, the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And we also remember our lovely right triangle. We've drawn in theta as our angle here, so what I'm going to do is label our triangle according to theta. So opposite will be over here, adjacent is going to be down here, and then our hypotenuse, of course, is always going to be opposite of our right angle. So right here you can see how we've labeled our right triangle. Let's go down below here and actually fill in what does sine theta stand for? Well, sine theta stands for, as you remember right here, opposite over hypotenuse. So it is literally opposite side, which I abbreviate OPP, over hypotenuse, which is HYP. Then we have the cosine. And cosine, you'll remember, is adjacent over hypotenuse. Adjacent side is ADJ. And of course over hypotenuse, HYP. And then the last one that we have to talk about is tangent. Tangent was opposite over adjacent, so opposite is OPP and adjacent is ADJ. Okay, so these are 3 of the 6 that we're familiar with. We shouldn't have any trouble remembering these guys. What I'm going to do is manipulate these 3 a little bit to come up with the other 3. So again, we know that sine theta is the same thing as opposite over hypotenuse. Well, what I'm going to do is take the reciprocal of sine, and you guys know reciprocal just means to flip it. So if I flip the sine theta, I'm going to end up with 1 over sine theta. And if I flip sine theta, I also have to flip the side it's equal to. So I'm going to flip opposite over to hypotenuse, and that turns into hypotenuse over opposite. This is actually another trig function for us. This one is called cosecant theta. We use CSC theta for our abbreviation, but the name of it is called cosecant theta. So the reciprocal of sine is cosecant. Moving ahead with cosine theta, we know cosine is SOHCAHTOA, so that would be adjacent over hypotenuse. Again, I'm going to manipulate this, and I'm just going to take the reciprocal of cosine. So reciprocal is flip it, so flip cosine to 1 over cosine theta, and then I will flip the fraction that it is equal to as well, so that turns into hypotenuse over adjacent. And this gives us our 5th trig function. 1 over cosine theta is the same thing as secant theta. We use SEC theta for the abbreviation. Secant is equal to SEC. So the reciprocal of cosine theta is secant theta. Okay, we're down to finding out our last one. I bet you can guess what I'm going to do here. I have the tangent of theta is equal to opposite over adjacent. So I'm going to take the reciprocal of tangent theta. So flipping both of those, it ends up with 1 over tangent theta is equal to adjacent over opposite. And this is what we call cotangent theta. COT is the abbreviation that we use for cotangent. So the reciprocal of tangent theta is equal to cotangent theta. Okay, we're going to start off pretty easy here. They've given me a right triangle, and this is a nice one. We know this is a Pythagorean triple, 3, 4, 5. Theta is one of our acute angles here. My directions say evaluate all 6 trig functions of theta. So they basically just want me to come up with the numbers for the ratios here. So again, what I would do when I start this problem out is I would go to my triangle that I have here and label everything according to the theta angle that they gave me. So 3 is going to be my opposite side, 4 is my adjacent side, and 5 of course is our hypotenuse. And if you think again in terms of SOHCAHTOA, I'll just write that here quickly. Kind of keep that in our mind as we go. Finding the SOHCAHTOA ones are always easy because that's where we're comfortable. So the sine again is opposite of over hypotenuse. Opposite on our triangle is 3. Hypotenuse on our triangle is 5. Finding the cosine of theta. Cosine again stands for adjacent over hypotenuse. So our adjacent side is 4. Our hypotenuse, of course, is 5. And then our third trig function that we should be comfortable with is tangent theta. Tangent stands for TOA, which is opposite over adjacent. Opposite is 3, and adjacent is 4. Now, I really like working with these guys because finding the cosecant, secant, and cotangent of theta is very, very easy. Remember how we derived cosecant, secant, and cotangent is we just found the reciprocals of everything. So all I'm going to do is take the reciprocals of the answers we just got to get the new answers. So cosecant theta is just going to be the reciprocal of sine theta, and reciprocal again, we're just going to flip it upside down. So cosecant is going to be 5 over 3, or if you will, that is hypotenuse over opposite. Secant is the reciprocal of cosine. So if I flip cosine around here, secant theta is going to turn into 5 over 4. And again, that's hypotenuse over adjacent. And then our sixth trig function is cotangent. It's just the reciprocal of tangent. Tangent's 3/4. So flip that one over. We're going to get 4 over 3, which is adjacent over opposite. These work every single time. As long as you know one of them, you can figure out all 6 of them. That is how you evaluate. Okay, same idea with example 2, except this time they only give me 2 legs, and I don't have the hypotenuse. So I'm going to have to use Pythagorean theorem here. I've got to do a little work before I can find my trig functions. So doing a right triangle, we do Pythagorean theorem. So I have legs squared added together has to equal my hypotenuse squared, which is, we'll just call that x for right now. 11 squared, of course, is 121. 7 squared is 49. And add those guys together, we get 170. Now, 170 is equal to x squared. I don't want x squared, I want x, so square root both sides. I get x to be the square root of 170. Of course, we're going to want to reduce that down. If at all possible, you would break down your square root, but the square root of 170 is not going to break down. So I know that I can now call my hypotenuse the square root of 170. Again, it would probably be beneficial to go in here and label opposite, adjacent, and hypotenuse on your triangle now. Opposite of theta is 7. Adjacent is 11. And we just found our hypotenuse, which was the square root of 170. All right, we're good to go. Now let's find SOHCAHTOA. Start off with sine. Sine stands for opposite over hypotenuse. So we have opposite over the hypotenuse. And of course, you know that we are not allowed to leave a radical in the denominator. So we would need to multiply by the square root of 170 in the numerator and the denominator to get rid of it. And I'm sorry, I'm going to have to squeeze here, right there. I have 7 square root of 170 all over 170. 7 and 170 aren't going to reduce down, so that is what sine theta is going to be for our triangle. Same thing for cosine theta, except this time it's adjacent over hypotenuse. And again, not allowed to have that radical in the denominator, so I'm going to rationalize that, ending up with 11 square root of 170 all over 170. And then tangent is TOA. That's opposite over adjacent. Thank you, that one.
Okay, in example 3 it says evaluate the remaining 5 trig functions of theta. So in this problem they actually gave me one of the 6 trig functions. They gave me cotangent theta is equal to 11/3. Now when I get a problem like this where they already give me one of the trig functions, I'm a visual person, and so my first instinct was to draw the right triangle out. So you can see I drew my right triangle. Here's theta. Cotangent is the reciprocal of tangent. Tangent is TOA, or opposite over adjacent. So the reciprocal is going to be adjacent over opposite. That's how I knew to label this side down here 11. This is my adjacent side. And then 3 is my opposite side. It's opposite of theta. As you can see, I'm missing my hypotenuse, so we're going to have a little work to do to go find it. I'm going to come over here and do Pythagorean theorem to find my hypotenuse. Remember, Pythagorean theorem just says take your legs, square them, add them together. That's going to equal your hypotenuse squared. My legs were 11 and 3, so 11 squared is 121. 3 squared is 9. Add those guys together, we get 130. Now 130 is equal to x squared. I don't want x squared, I want x. So just to solve, I take the square root of both sides. I get x to be the square root of 130. Now if you can break your radical down, you should do that. However, the square root of 130 doesn't reduce down any farther, so I know that that is going to be my hypotenuse. Okay, here comes the fun part now. We got to find the other 5. Now remember in my directions they told me that cotangent theta was equal to 11/3. Now I am incredibly lazy, as you know. And so the first thing that I would do here is go and find tangent theta. I know that cotangent and tangent are reciprocals of each other. So if cotangent theta is equal to 11/3, tangent of theta is just going to be the flip of that, or the reciprocal. So tangent theta is going to be 3/11. Super easy. All right, let's find sine theta. Sine is opposite over hypotenuse. Opposite on our triangle is 3. Hypotenuse is the square root of 130. And as you know, we're not allowed to have a radical in the denominator. So I'm going to rationalize that by multiplying the numerator and the denominator by the square root of 130. That's going to leave me with 3 square root of 130 all over 130. Now what you want to do is see if your fraction will reduce down at all. 3 doesn't go into 130 evenly though, so I know that I am done. Right there is sine. Okay, for cosine then, cosine is adjacent over hypotenuse. Adjacent on our triangle is 11. Hypotenuse is still square root of 130. Again, can't have that radical there, so we're going to rationalize. Multiplying numerator and denominator by square root of 130. That leaves me with 11 square root of 130 all over 130. Again, check to see if your fraction will reduce at all. This one doesn't, so I know I'm done with cosine. Okay, we have 2 left now. Cosecant is the reciprocal of sine. So to make it easy on myself, I'm going to take the original value of sine that I had, which was 3 over square root of 130. Take the reciprocal of it, flip it around. Cosecant theta is going to turn into the square root of 130 all over 3. Secant theta is the reciprocal of cosine theta, so take your original cosine value, 11 over the square root of 130, and flip that, take the reciprocal of it. So this is going to turn into the square root of 130 all over 11. And that is how you find the 5 remaining trig functions of theta when you have been given 1.